Hello everyone and welcome back to our course on TI84 calculator. In this course you're going to be learning about how to apply TI84 Plus CE from Texas Instruments. So why am I choosing TI84 Plus CE? Is because this is a calculator authorized for use for international baccalaureate. So if you're an IB student or someone who is planning to take standard tests such as SAT or AP, this is a calculator allowed for your exam. So it is allowed for the normal SAT as well as for the SAT subject test, and moreover it is also allowed for AP. This calculator is pretty useful if you are a high school student because there are some better calculators which are more functional. They are not allowed really in some examinations such as IB, for instance TI Inspire. So it is not pretty suggested for you to use some more advanced calculators, although this one is already pretty advanced. So let's start right away. So if you're joining this course and looking at this video right now, I assume you are a beginner in using TI84 because I don't really want to go through this pretty fundamental stuff with you if you already know about them. So otherwise, you can go straight to other videos which I've titled the content of each video, so you can see which one do you need help. You just have to click on that particular video to see the important concepts. So today, let's start from the beginning. If you have the real calculator, it is pretty easy to close. To close this calculator, you have to do second and on. So in this case, you're going to close it, but now we're not going to show that in here because now this is a digital calculator. But if you have the real one and you do second and on, you're basically close the calculator because you see the blue text right here is off. So if you do second, you are enabling the second function, so you'll say off. And why second important? Because if you can see with many functions here, for example, we have the sine, cosine, tangent with 1, 2, 3, 4, 5, 6, 7, 8, 9, and you see all these buttons right here have a blue alternative. So how do you enable the blue part? You just have to do second. So for instance, if I have 4 right now, and when I do second and 4, I'll basically enable L4, which is list number 4. And for sine, if you just do that, you'll have sine. But if I just click sine, you'll be sine. But if you do second and sine, you'll basically have sine inverse. And the same applies to cosine and tangent. So this is basically how it works. And to clear, you just have to do this clear button here. So this will be your friend, which you are using it to delete your equations and so on and so forth. Now, when you got a calculator, it can be fairly complex because it is too functional. But what is the main page? So the main page is basically second and mode. Because after second and mode, after you chose second and mode, you're arriving to this blank page. And this blank page allows you to do basic calculations. So you are going to do the calculations on this page. For instance, if I want to do 5 plus 5, so very basic, I can do it here. If I want to do something like this, I can do it here. If I want to do a sine 4, I can do it here. If I want to do a square root, for instance, if I want number 5, I want to do something like this. Maybe, let's do a large number, probably this. For instance, 96 to to the root of 6. You'll get a result. So this is always your best friend in this calculator because you are going to be navigating to many different places. For instance, you might go to apps. So in apps, you have a lot of functions such as finance, such as a Capri Junior. You can have a sales sheet, you have a connect, you have asset data. So you have many functions right here, which we are going to go through later. So I'm going to teach you how to do a finance calculator of a time value of money, but that is later. So for instance, if I'm calculating something here like IRR or finance, and I want to go to a main page, so then you just arrive and you just choose your best friend that is second and mode, because otherwise then you can quit and go to this main page that is pretty useful. Not only you should go to this page when you are done with a particular calculation you want to arrive at the main page, but this page is also important if you want to do calculation, because this page is like similar to a normal calculator, your normal simple scientific calculator where you perform this basic arithmetics. So this is pretty important. Okay, so since it's our first video and I know many of you are concerned about graphing, because graphing is basically I would say the key reason why many of you guys are using the graphing calculator. As you can see, infer from the name, it says graphing calculator. So in graphing calculator, you're going to be using the graph button right here, and you are able to draw a graph. That's why it is called a graphing calculator. And now let's perform how to draw a graph. It's pretty easy. When you just click graph, you are going to see this standard scaled graphing graphing Cartesian plan. So now you have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 10, 10. So you have a x minimum of 10, x maximum of 10, y minimum of 10, y maximum of 10. And now let's draw, when you want to draw a graph, you just have to go to this y equal button. And now you can see you can draw like a maximum of 10 graphs. Actually, it's pretty useful, but you can do more, but normally we don't need that much. So let's now start with linear graphs. So let's give us a brief recap. I think many of you know what is a linear graph. It basically involves x to the power of 1. So for instance, linear graph can be 5x plus 3. For instance, so x is here. If you can see x, t, data, and n, they are both here. So for instance, I want to do 8x, let's say ax plus 3. So this is a linear graph, and linear basically means a line, as you can infer from the word. So what we'll get after this is basically when we graph it, we'll get the line. Pretty easy. And the second graph I want to try for you guys is a quadratic. So if you're a high school student, I assume you guys all know about quadratic, that is involving x to the power of 2. So for instance, let's play around with 5x. So now you need to do a square. How do you do the square? It's pretty easy. Of course, you can do it here. If you do a second, sorry. You can do a square here. If you, for instance, you can say you can click this and you get a square. But now I want to introduce to you where you can do a power, or some people will call it exponent in this graph. So for instance, I want to do 5x squared. And now I have x, and remember this button is your friend when you do exponents. So if I do here, it will lead me to this little right upper space. And if I want to do a square, I just go 2. And remember now you've done the square, but you still stay on the sky. So you want to go down. So now you have to do, what you have to do is click the right button, and now you're done again. So now I can do some addition. For instance, I want to do 3x. And now I still need to plus a 8 to form a quadratic. So now this is our quadratic equation, which will supposedly have 2 roots for x. If it's larger than 0, let's graph it to see how does it look like. Oh no, yeah, this is my quadratic, but it doesn't look it doesn't look clear to me because most of its part is covered by the calculator. So how do I do this? It is another concept you should keep in mind, you should pay attention. It's how do we change the scaling. So now this is basically the standard Cartesian plan. You have 10, negative 10, 10, negative 10 for both x-axis and the y-axis. So now if you want to make changes, you remember to go to so-called window. And if you go to window, you can change maximum, minimum, and maximum for both x and y-axis. So now, just now, I don't have to change this, but you see, I cannot display my graph pretty well. So now I have to change probably x maximum. 10 isn't enough. How about let's do 100? So now I've done 100, and if I draw my graph again, you can see now my quadratic is pretty clear because I've been extending, I've been increasing my x maximum. So now you can see the graph is pretty clear. If I want to turn back to standard, for instance, because now my y scale is 100. If I want to turn it back to standard, I basically go to window again. Actually, you can do it manually. So one method for you is just manually do it and change it to 10. But another method is for you to go to zoom. If you go to zoom, you can see number 6, it says zoom standard, Z standard. So if you type 6 on the calculator, you basically automatically transfer back to the Cartesian plan that you started with, which is 10, 10, 10, 10. So I hope it is pretty straightforward. So now we played with a quadratic, we play with a linear equation, and now let's do a cubic. Does anyone know about what is a cubic? I don't. I think you guys should know about that. I hope you guys know about that. It's not really complicated. Cubic is basically x to the power 3. So let's play with, let's choose a small number. For instance, 3x. Let's do a cube. So same thing again. You do this 3, and then you have to do this to go back. And maybe let's keep it 2x squared. We can just do it here. Sorry, we can. Oh no. Wait. Sorry. So 3x to the power 3, which is 3x cubed, plus 2x, and now I have a square, plus 3x, plus minus, let's do minus 6. So this is a example of a cubic equation involving the x to the power of 3, power of 2, and power of 1, and a constant. So if we graph it, we'll see a cubic equation. So you might have known about this. I think you should have covered about cubic in, I would say, year 10 or year 11. So quadratic is basically something like a parabola, and cubic is basically two parabola. But you can see it's bigger, but it's not two complete parabolas. It's basically one, and it has a turning point right here. So first of all, it may look like a parabola, like one side, and then it turns. So this is an example of a cubic function. Okay, so this is the introduction to how do you graph the linear, how do you graph quadratic, how do you graph the cubic equation. And now if I want to delete them, I just have to go clear and clear and clear. So now I have all those three clear. Now, that is just basically how do we graph, how do we do the basic graphing. And now I want to introduce to you guys how do we find the roots of a parabola. So if you've been doing high school, I think you have learned about how to manually calculate the root. So for instance, if I give you a number, I give you today, I want to keep it simple today. Let's say x squared plus 5x plus 3. So now I want to find the roots. What do I mean by finding the root is basically to find what are the result of x when y is equal to 0. So now we know how to graph it. It's pretty good. I think I don't have to change the scaling. The scaling looks perfectly fine. But now I want to find basically what this point are, what these 2 points are. I don't have to do it manually since we now have the graphing calculator. So I can basically use a so-called pretty easy method to find. I'll guide you through that. How do I find these two roots of x when y equals to 0? So now we have the graph right here. And how do we find this? Basically, we go to second window. Okay, second. Wait a while. Yeah. Wait. Second trace. Sorry. So now I'm introducing to trace. So if you go to second trace, what you can find is yes, you have 7 different functions in trace. Sorry, you have to remember to do second trace. It's not only trace, it's second and trace. So now you can see 1, 2, 3, 4, 5, 6, 7. You have a value, you have 0, you have minimal, maximal, intersect, dy, dx. You can do the derivative, and you also have integration. And now I want to find the rule. I have to let y equal to 0, isn't it? So I have to do 2. I just click 2, and now you can see it asks you for something called the left bound and right bound. So this is basically you have to locate where's your rule. For example, I have 2 rules. I'm doing on the right first. My root is here. And now I have to go to the right bound. So after you go to the right bound, which is the right side of your root, it doesn't have to be so accurate. It can be here, it can be here, or it can be here. It just have to be something that is on the left of this bound. But don't also go too far. If you go here, it may wrongly recognize your root to here. So since your root is here, you try to stay as close as possible. So I'm going to the left of the root, and now you just have to do enter. After that, it's going to ask you for the right bound. So my root is here, so I have to go to the right side of the root, which is about here, and then do enter. And now it asks you to guess. You don't have to care about that. You just do enter again. And now, congratulations. You found your first root, that is negative 0.697224. So usually in the exam, you can just note down this in possibly, I would say, 2 decimal places or 3 decimal places into a notebook. So this is about your first root. And now I want to find my second root because since it's a quadratic, it should have 2 roots. As you can see, 2 different x points lie on y equal to 0. So basically, I just have to repeat my step. Second and trace. After that, I go to 0. And now it asks me for the left bound, which is here now, because now I'm doing the second root. And here's my left bound. My right bound is here. Yes, I just do enter again. Congratulations, you found your second root. This is about negative 4.3. So in the exam, you just have to copy down this 2 points in possibly 2 decimal places onto a notebook. So this is our first skill we need to learn about how to find the root. And now I want to find what is the y coordinate given a x coordinate. For instance, if I ask you, what is y when x equal to 2? What is y when x equal to negative 2? Sometimes it's pretty hard to examine when we use our eyes because parabola usually have a symptom is kind of going through it, and it's pretty hard to actually see the accurate number. So how do I do that? Is pretty easy. So now I have a graph here. I just have to do trace, and I just to do a number. You don't have to do second. You just do trace. After trace, you just type in a number. For instance, say 8. So now I'm finding when x equal to 8, what is my y value? So we just do enter. Boom, y equal to 107. why it's so useful is because I can see y equal to 107 here, and in your exam you are not going to draw a graph until y equal to 100. So this is why graphing calculator is pretty useful. So when x equal to 8, now I found that y equal to 107. For instance, I'll try again. I will try negative. Trace, I will say, for instance, -6. I don't want to confuse you. Remember, negative and subtract signs separate in a TI84 graphing calculator. So when you're subtracting, you're going to use this sign right here. When you are going to annotate and going to indicate a negative number, please use this sign right here. Otherwise, the calculator will not be happy. So for instance, x equal to -6, I found out y equal to 9. It's pretty useful. So this is the second skill we need to learn. And the third skill is to find the intersection between two graphs. So now, for instance, let's draw the wave quadratic, and now I want to add a linear graph to our set. So after we add the linear graph, we're going to be finding out the intersection point between these two graphs. For instance, let's just do 5x plus 3. Okay, so now we have two graphs. Boom. We have two graphs right here, and you can see the two graphs do intercept. They do contact each other, so we're able to find the intersection point. As you can see, the intersection point is actually here. And how do you find it is actually trace again, do second trace. And now you can see number 5, it says intercept. So you just click number 5 in your calculator, and now it asks you first curve and second curve. So my first curve is, I should go down a little bit so I don't confuse my calculator. For instance, I go here. So you just have to find a point where it is, where is your curve, and you just do enter. And the second curve right here, actually I find a point. So this is a bit different from the last thing we do, because last thing we have to do the left bound, right bound. In this case, even if the intersection point is here, you can still do the first curve and second curve thing far away. Just now I did my first curve here and second curve here. You still find the answer. So my answers for the intersection is 6.37, e minus 7, and 3. So it's pretty easy. You see how convenient it is? And now this is the third skill. I think everybody will follow me on this. So you guys should understand how do we find the intersection. And now we're going to do our fourth skill, which is how do you find the minimum point. So let's delete my linear friend right here because I don't need it for now, since linear graph doesn't have a minimum point. It goes forever, unlike a quadratic function. It has either a maximum point or a minimum point since it's a parabola. So let's clear this first, and let's graph solely on our quadratic. So now we have the quadratic, and you can see just by your eyes this quadratic has a minimum point, because in maximum it is actually going out to infinity, and it doesn't have actually a maximum point, but it actually have a minimum point right here. And although in this case you can actually see it is about -3 point something, but we cannot see accurately. We cannot measure it, or maybe we don't have a graph paper with us when we're doing examination. So now we're just going to apply second trace again. And as you can see, we've already made friend with our number 2, which is how do you find the roots with y equal to 0. And we also learned about how do you find the intersection between two graphs. And now our friend is minimum. So if I do 3, it asks me to find the minimum. It asks me to do the left bound, right bound again. So what do? Is you get the left bound, and you do enter, and it asks you for the right bound. You have to go to the right side of your minimum point. This is your turning point, or in calculus it is called the stationary point, and just do enter. Guess you don't have to do anything about it, just do enter, and boom, you have the minimum point that is about -2.5 and -3.25. So you can note down this point in your examination paper, and you are pretty much finished with finding the minimum. So let's now give an example to how to find the maximum, but it is pretty easy. How do you find it? So I just have to change this graph to, for instance, like a negative x squared. It will be pretty straightforward, because when it starts with negative, usually it is a maximum graph. Okay, so we have our graph right here. Oh, sorry, I did a negative wrong. Yeah, it's a bit confusing. Remember, I've told you guys that for negative, we have to use this, so we have to use this sign. Yeah, now it's fine. See, okay, this graph, as you guys may know, is a graph including or involving a maximum point. As you can see, the minimum point is going down to infinity, so it doesn't really have the minimum point is actually negative infinity, and maximum point. I know you guys may be able to see the maximum point here, but you know, sometimes it's hard to determine the x-axis and the y-axis when you don't have accurate calculation or accurate measurement. So for instance, now we want to find it. It's pretty easy. We just do a second trace again. Remember our friend I did intercept. Remember our friend minimum maximum. Now we're going to choose number 4, and it asks me left bound. So left bound is pretty much about here. The right bound is about here. Again, you don't have to do anything. Yeah, then you have your maximum. C is pretty hard to measure because it's like about 0.49 or 2.49. I would say it's about 2.5. You can drop down the answer. And Y is 9.25. So this is how to find the maximum point. Okay, hope you guys have mastered how do we find the minimum and the maximum point. And I just want to emphasize when you found the result for your minimum maximum point, the x coordinate will be your line of symmetry. Remember, when you have two roots, the line of symmetry is basically the middle line, the median line of two different points. And when you sub in your line of symmetry, which is the x-axis here, if you sub in this x coordinate of your symmetrical line of symmetry, if you sub in, you'll find your minimum or maximum point. So when you're using a calculator, you're not only finding the minimum maximum point, but in one go, you're also finding an x. And the x will be a line of symmetry that is the median result of the two between the two roots. For instance, if you have rule 3, x equal to 3x equal to 5, your line of symmetry is basically 1, because 5 minus 3 is 2, 2 divided by 2 is 1. So that is something I want to emphasize today. Okay, so now you know how to do it. Now you know how to define the minimum maximum point, how to do intersection, how to trace the root. And now it's pretty much finished in terms of basic graphing. And I'll see you in the next video when we are going to be talking about how do we do simultaneous equations. I will see you there.